Hello, grade 9 math students. It's Ms. Stone, and this video here you have Mr. Burgess with you, I think, today, which is fantastic. And I'm just making a video to go through the lesson, so you still hear the lesson in my words, and it's still just to keep it familiar for you. And certainly without me here, to me the class still runs as normal, though if you look at the list, the order of operations here, I chose today to do your group work at the end of class instead of the beginning because it really it involves using some of the stuff that we learn in the lesson. So we'll just do the 3-minute review and you'll hand it to Mr. Burgess. You'll copy down the note and you can of course stop and ask Mr. Burgess for help. The other important thing as you take down the note is I go pretty quick to keep the video short. But just, keep in Mr. Burgess and you can work together and you can pause the video as you need just to catch up on my writing. So I'm not going to pause for you to write. I'm going to assume that you'll pause the video and then catch up when you're ready. The question on your own, I have a solution here you can see so you can check your answer. Mr. Burgess will hand it to you. And then yes, in the group work, I think I might have mentioned it, you do get to pick your partners today. And I do expect you to finish it though and submit it before you leave today. If you happen to get everything done, then maybe you can have some free time at the end of class, okay? And I chose to put this picture here because that's my 2 puggies, and we're sitting on the couch right now, and they're beside me, and this little black one, Winston, he was just snoring and sleeping, so I thought I better, if they start to get noisy and you hear some weird noises, it's not me, it's my 2 pugs. This is Charlie, and this is Winston. Okay, next. Oh, that's the group work. We'll get to that later. Okay, so here's the lesson you should find. Now, it's in the new package that we started the other day that says Chapter 6. If you don't have a copy, Mr. Burgess should have one for you. So please, I'm going to keep talking, but you might need to pause to make sure everybody's got that and is ready to go. I assume by now you've also finished your 3-minute review and handed that in. If you haven't finished the 3-minute review, don't take this video down until you have, okay? All right, so here we go. So here's your first example. It's all about the idea of speed, and we've hinted at this already. We've just actually not calculated it from a graph. And we're learning a new term today, and that new term is rate of change. And rate of change is probably the biggest, most important concept, I think, of grade 9. And certainly you'll see it as long as you're taking applied or college stream level math. You'll see the term rate of change, and sometimes slope instead. And we'll see what that means. So we got Roshia here. She rode her bike 4.5 kilometers to her friend's house, and that ride took her 15 minutes. So graph it. Now there's not a lot of information. You can see all the stuff on the graph here, but your graph doesn't have much. So you might ask how I knew to draw this line. And if you look at the 2 little red dots, I see that as the start and the finish of her trip. She started like 0 time and 0 minutes, right? She didn't travel anything before she left. So that's that red dot. This red dot means 4.5 kilometers if you read across. If you look at the scale, it seems to go up every 2 boxes is 1. That would make this 4.5 where my little cursor is. And 15 minutes is down here. So that dot means sort of her second point on her journey. She started at 0, 0 and she finished there. So things you should be copying down. You might be copying down this rise and run and you don't know what the heck I'm talking about, but I guess you're maybe seeing it. But as you get the graph done, you will see you're going to want to copy this triangle, right? And we always use a triangle to help us find rate of change. The bottom part, it's always a right angle triangle. The bottom part of the triangle is what we call run. And you can measure run by how much it goes over. So it starts at 0, it ends at 15. So the run is 15 and it's minutes because that's the unit of that axis. In these graphs today, it's always time on the bottom and distance on the side. They're distance time graphs. Okay? And rise is how much it goes up by to that dot. So I made a triangle, and we'll talk about the triangles a bit more later in the lesson, but it's easy. It's really easy if you start at 0, 0 just to make a triangle sort of covering your whole space. So the run is how far it goes over by, rise is how much it goes up by, and I have more for you to add here once you get all this down. Again, pause it, please. Don't rush, don't let the video rush ahead of you. But underneath here, rate of change, for writing purposes, I just say ROC. I don't write the word rate of change. So ROC for rate of change, and that's what it says here. What is the rate of change of distance with time, and what does it represent? So rate of change, first of all, ROC, and what it is, how you find it, is the rate of change is rise over run, and that's an expression we'll use a lot for the rest of the semester, rise over run, okay? So rise, again, is how much, in your triangle, how much you go up by, and you can read that off of this scale, the side scale. The run is how far it goes over by, and you can read that off the bottom scale. So rise is 4.5, right? The run is 15. So if you divide them by over, remember a fraction is just a divide, so 4.5 divided by 15 works out to 0.3. And I put the units with it because with rate of change it matters. And the rate of change is always like, this is kilometers was on top, 4.5 kilometers, and minutes on the bottom, so it's kilometers per minute. And for today, that's commonly going to be what it is. It's always going to be something that reflects a speed, because rate of change is speed. Okay, so finish copying that, but I'm going to move on. So what if you know her speed? So we know her rate of change, her speed in kilometers per minute. If you want to find it in hours, because there's 60 minutes in 1 hour, if she can go 0.3 kilometers in 1 minute, then she can go, multiply by 60 to get how far she can go in 60 minutes, okay? Again, I'm just going to keep plugging away. Run in and recognize you'll stop. Example 2. Deshane took 40 minutes to drive to a party located 50 kilometers away. So assuming he made no stops, graph his journey, graph his distance and time. So again, we're assuming he started at 0, 0. I tried to draw, you can't see them that well, but the little red dots. So 0, 0 is where he starts at 0 minutes and 0 kilometers. And he finishes at 40 minutes and 50 kilometers. So that's the end point. So you draw a line to connect them, and that's the graph that represents his distance time. So finding the rate of change. So to find the run, you draw a triangle, okay? A right angle triangle from the start. It's usually easiest if you go from the start to the finish, but again, it doesn't have to be. But you make your line into a triangle, and how far it goes up by is called the rise, and how far it goes over by is called the run. And so the orange, how far it goes over by, is it goes from 0 to 40 minutes, so that's 40, and the rise goes from 0 to 50 kilometers, okay? And so rate of change, rise divided by run, 50 divided by 40, and the units are just the same as this, kilometers here and minutes here. Okay, kilometers per minute. What does it represent? There's the question, and in this case, in all of the cases today, it represents speed. Now, a great question might be, if someone left at the same time as Deshane and how they were driving faster, what would their graph look like? And maybe you guys can talk about that in class today. Anyway, what was his average speed in kilometers per hour? Multiply by 60. Okay, if you know it per minute, to get from minutes to hour, you multiply by 60. Okay, this example is here to show you that both triangles I did before, I started them at the bottom. And you should know that you can start them anywhere on the line. And so this one very specifically is added to show you that I could do this same rise over run and get the same answer even if I didn't start at the bottom. Okay, I could do this at the bottom to the top. I could do this, make a triangle right here, so if you can follow my cursor along the bottom, I could make that my triangle. That would be an accurate and correct way of doing it. But this example is very specifically to show you that you can be just as correct by choosing a smaller triangle. Okay? So here's the triangle, and I just want to make sure you're very clear on where this 4 kilometers and where the 60 minutes comes from, because you might look at this and say, well, it's 6. Where'd she get 4 from? Then you might look at it and say, well, there's the 4, and that's not exactly correct. The 4 happens because in the triangle I chose right here, it starts at 2 and it ends at 6. So it goes up by 4, therefore the rise is 4 kilometers. And with the run, it's harder to tell this, but you can see how it goes 0, that must be 30, and 60, and that must be 90. And every box you can tell is 30. So it goes over 2 boxes. So the run is 2 boxes, which is 60 minutes. So again, you're not using the first number, you're not using the middle number, even though it happens to be in this case, and you're not using the last number. You're using how far it goes over from the start of your triangle to mine. And I could draw a triangle anywhere as long as I use the rise and run that go with my triangle. So I say 4 kilometers in 60 minutes for my rate of change, and if you calculated that out, rise over run, you end up with 4 over 60, and my divides are pathetic, but it's all I've got with this technology. It's the easiest I had with this technology, and it ends up being a really tiny number, but because usually people can't travel that far in a minute, especially if you're just learning how to inline skate. Oh, excuse me. You might hear a little puggy. He's every once in a while snoring. Anyways, rate of change in this case is speed. Okay. Yeah, I just woke him up. Okay, one more example. And this one is a hiker, and I chose for this one again not to use the triangle. You could have used the full triangle for sure, starting at 0, coming right across. I just chose to use a different one. And I'm going to use the points. See the little dot there? It refers to the point 1 and 4.5. And remember that 1 means how far, like on the X, on the bottom axis it is. And the 4.5 means how far up it is. And similar over here, okay? So I chose that point, but I could have done it from here to here. I could have done the whole thing. I just wanted to show you the example to make sure you kind of get how to do it this way. Because there's times where we're going to do lines later on that don't even cross through 0, 0. And I want to make sure you know how to work with those. So anyways, here this yellow line is going to represent my run. And this orange line is going to represent my rise. And see if you can guess what, before I open it, maybe take a second and guess what the rise is going to be. Okay? And then guess what the run is going to be. I'm going to just pause the tape for you to make your guess. Okay, and hopefully you made a guess on rise and run, and let's just see if you're correct. The rise, how much it goes up by. I found it out by saying, because it goes from 4.5, right here, 4.5, and it goes up to 18. So it's got to be the difference between those 2 points, and you can find it just by subtracting the big number, subtract the little number, and you get 13.5. The run is how much it goes over by, so it starts at 1 down here, and it ends at 4, so it's going over by 3, right? 1, 2, 3. So I'm using a rise of 13.5 kilometers and a run of 3 hours. So then you just divide them out and you get your answer, and it does represent speed once again. Okay, so I think that's the lesson. I want you to try a couple on your own. Take the time to make sure you get it. Ask for help, and make sure you get these two. Good effort on them, and I'm gonna you should be getting them handed out to you maybe right now. And then I'm gonna take them up in a moment. And again, I'm gonna just continue, but I assume you'll pause for a minute. Take 5 minutes to try the question. Both questions, there's 2, and see how you do. Okay, you should pause now. And where is it? There's the solution. Okay, we're back. So here's the solution. It's messy, but to finding the rise and run and the rate of change for each of these graphs. For both of these, because it's easier, I did start at the bottom, but you didn't have to. Okay? So my purple represents my rise of 320 because you can see it gives you the number right there, right? And if you come across, it's near 300. That's what that number is. And the run is how far it goes over. So it starts at 0, comes over to 4. So that's a run of 4. So the rise over run is just 320 divided by 4, which equals 80 kilometers per hour. I knew it was per hour this time because this unit is hours. Okay, the next one, checking your answer, 45 kilometers is how much it goes up by in the red, starting at 0 and coming up to here. And the run is that it goes over by 3 hours. So divide them and you get a rise over run of 15. Fill that part in, check your answer, and hand it in, please, to Mr. Burgess. And then probably it's time, I want you to maybe, before you get together with your partner, let me show you. This group work is using rise over run, but it has a couple of different parts that look different than the examples. So you're really going to need to get help from Mr. Burgess and look at the 2 examples that I'm going to show you on how to do them and see what you can argue out and figure out with your partner. When you work with your partner today, I do want to see 2 different color pens for equally shared work, okay? So you can use red and blue, pencil and red, pencil and black, I don't mind, but 2 different colors, please. So our group work, again, is, here it is. Oh, come back. There's the piggies. Okay. So this gives you a distance and time graph, and we saw graphs similar to this in the last unit, but the challenge is to find the rate of change for every part of this graph, and this is a little different than the examples in class, so please take a close look through as I show you. I'm going to show you how to do it for C and D, okay, and then I hope you can kind of figure it out for the rest. So Chris runs each day as a part of his daily exercise. So here's his distance time. I filled in like little red just to sort of get the numbers on here. This one is a little tricky, but if that's 200, it must be going 200 every box. So 200, 400, 600, 800, 1,000, 1,200, 14. And what I want to show you as an example, because you know you'll probably get A and B because it's going to be exactly like what we did in class. B and C, C and D, like all the rest are different. So let me show you C and D, because the idea of the triangle and the rise over run, in this case, my triangle's not that visual, but there's the bottom, okay, and that's the run, sorry, down at the bottom, and there's the rise. So the triangle that you draw, you can just draw it between the 2 points and you make it a right angle triangle. So, I mean, similarly, sorry, I'm going to make these a bit more visual, actually. They're pretty pale. Make it red, maybe. So my rise on this one, sorry. My rise on this one is going to be from here to here. So that's for CD. So it starts at 1,000 and it goes up to, watch my mouse, it's coming across to 1,400. So the rise is 400. And the run is how far it goes across this way. So that's 10 to 15. So that's 5 minutes because it starts at 10 and it ends at 15. So it's how much it changes. And so for E and F, for example, and I'll just tell you this one, the rise will be a negative number. You just put negative. It won't change your question at all. But you're going to say it starts at 1,400, ends at 0. So the rise should be negative 1,400. And the run, that's going to be 25. So the run is going to be 5 minutes. Okay? So you're going to do that for AB, that section, BC, CD, DE, EF. Okay? Each section. And then let's look at the next part. This one's similar, where you have to answer why are some parts steeper, and what does that, mostly just what does it mean. But so here's Mika's mother sending him to the corner store for milk and tells him to be back in 30 minutes. So he takes 40 minutes, first of all. But it asks us to find the rate of change for each section of his walk. So he goes A to B is the first section, similar to the last question, B to C. So for each of these little sections, you're going to make their own triangles. So I'm kind of trying to outline it right here. C to D, And I wanted to give you an example for EF. So in E and F, here's the rise. Do you see my mouse? So it starts at 600 and goes down to 500. So I call it negative. And anytime that looks like that, what we think of as a negative trend is a negative rise. But the run is always positive. So it goes over by, and it starts, I just drew the orange lines to make it easier, but starts at 20, ends at 28. So the run is 8, not 28, not 24, nothing like that. It's 8. It's how much it goes over by. And then you do your calculation, that divided by that. Okay, so you got to do it for all those sections, but you should have lots of time, and you get together with your partner, and you can make your own partners, and then if you're not sure, Mr. Burgess will help you sort out the rest of the groups, okay? Well, I think that's all I have to say. I hope you have an awesome weekend, and I'm looking forward to reading this stuff. I'm going to come pick it up at lunchtime, so I'm expecting that you'll have your group work done, and your 3-minute review done, and your exit card done. Okay? That's it. That's all I've got to say. See you Monday.